Hello, and welcome back as we continue our course on data science under Introduction to R. We are still looking at R environment and the R data type, control structure, and the functions. So now we are looking at functions in R. What are functions? Every programming language has functions, and they have uh, 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 uniform patterns. All right. Only the language that is different. Functions are one of the fundamental building blocks of the R language. They are simply pieces of usable code that can be treated like any other R object. You can create a function and save the function, then call the function to be used many times as many times as possible in any R language. All right, so that's the function. We have a function called sysdate. This is a system function, inbuilt function in R. So you can see sys.date. So you can run this function to give you today's date. If I run this date now, function gives me this today's date. All right, I'm running this on the 20th of April 2024. So that is give me today's date based on my system date. So we have several functions in R. I mean, different way to create function in R. Okay, function must be first declared and assigned to a variable. All right, so we create a function and assign to a variable. That variable will become the function. This is the function now. All right. So when you want to use this function, you have to call it. All right, to be used. So this function is taught to add two numbers together. Let's start with that first. How we add two numbers together by using function. That's what is called parameters in function. The parameter is what you pass to the function to give you results. All right, so we have function. This is how to declare a function now. Write a variable here, right? Assigned to a function. It's a function. This function is a keyword function. Open bracket. First parameter, second parameter. We want to have two numbers, a and b. It can be c and d. It can be any parameter you want to pass in. We are not using 1 and 2. We want to use an element or a variable to denote our parameters. Okay, so we can now change it in data as many times as possible. We can change it to maybe 1 and 2, 3, 4, 10, 20, 100, 50, depending on what we want to pass into the function. All right, so we now set a result, and another variable now, result equals to a plus b. So what you have here, we want to add it together to give us the result. All right, so we return result. A function must return a value, and the value is the what you calculate. So we calculate the result, which is a plus b, and that's what we return. So we are finished. The function has finished here. All right, we open the function curly bracket and we close it here. So we have finished the function here. So this function now cannot be directly used on this. It is called. Every function must be called to be used, not only in R, even in Java, in Python, you have to call a function to use the function. All right. So now we want to call this function now with this parameter or arguments which we're going to pass into it. Let's say we create a new variable right now. I create a new variable called sum result. Hard numbers. Our function name is hard numbers. So we call the function name, we pass a and b. So a and b is now 5 and 7. We can pass anything to this function, 20, 30, 50, 60, whatever we prefer, we can pass into this function and it will give us the result. So we can say print, paste, don't mind this, but just try to, if you have multiple of a print you can supply, so we can remove this paste for now. So print sum result. This is our this particular one. You can actually just pass this out, print this out, you give a result automatically. You just say sum result to give our answer without using print. If I say sum result to give me the answer of this function automatically. So let's first run the function first. Let's run the function. We run this function. All right, it's been run. So let's call it. Let's assign variable to it. And we are calling the function now. We call the function sum result. So let's print out the result. Let's just use this one only first and see the result. Can you see give us 12? Right. So the same thing this guy will do. We just have to say that we are going to print string together. Sum is 12. So we have to add string together with the result. That's what we do here. We concatenate okay, string plus the result. So, but at least actually the result is this, all right? That's what we are looking for. That's first example. Another example is function with a default parameter. Okay, you already assign parameter to the function already. For example, here we can assign parameter to, you can say this one is equals to 10, this one is equal to 50. So this, yeah, that means you have initialized your parameter or your argument with a function, with a number, okay, with what we call parameter. So here we have example, greet user function name equals to guest. We already pass guest to the name. Automatic name is our parameter here. So this is a value. We are passing a value to this parameter. All right. So we can now create a new variable now called message. Paste hello name. So this name now, what we will print out is to print guest out. This guest will be printed instead of name because this is our function name, our parameter name, and this is our value. So already assigned value to it. So you can change the value later to something else. So if you return, it will return message now, which is our what we want to return message, and that will give us a guest. So we can call the function here. Let's run the function first. Let's run this guy. Run. So we can call it a default greet user. So when we call the function greet user, because it's already have parameter passed to it, so we just use greet user because something is already passed to it. So it will print out this answer. So we can print out our answer now. So hello guest. So because already have a parameter passed to it, so we don't need to pass anything. If you want to pass anything, you can change it here inside it here. Okay, you can just name equals to something else. You can just add your name here. Okay. So we can call a function with a specific name. Look at it now. So this function can be called. We can want to call. Okay, let's pass John in. We pass John into the same function. Okay, and that's a print custom greeting. Print the function now. Let's print the function. Okay, hello John. Okay, so we pass John. Say hello John. You can see. All right. So because the name is what guest. Yeah. So we can change the name to either guest or John, whatever I want to use it for. All right. So this is a function we have created. So message to be hello, that name we pass it. All right. So any name you pass it will automatically show, and I put this and this automatically together. So this is how to create. This is what they call string function, a function with character. But you can not a function and also make it open function with a variable of numbers of arguments. The number of argument is variable, which means that it differs, it changes along the line. So it's not defined. That's what it means. It's not defined. So to calculate average, let's calculate average function. We use dot, 3 dots. Take note of this, very important, because this is an unusual declaration of function in R. R gives room for this kind of function. It gives room for it. So you can create a function in R with variability of numbers. Okay, values equals to C dot. We are not passing anything to this. It means it can take anything. That's what it means. It's open for anything that is coming. All right. So we want to say, okay, average means values. This value equals to this. So we are not passing anything yet. Average equal to means value. Whatever we pass into the function, that's what we take. That's what are we saying? Don't know the number of parameters before we pass parameter number, 2 parameters here. Okay, here we pass 1 parameter here, but here we don't know the parameter we want to pass. We don't know it yet. So it can be many, it can be 10, 20, 30, 40, 50. You don't know. You just make it open. All right. So any parameter you want to pass in to this function called calculate average. So our value is C. Anything we want to pass into it, then average equals to mean values. Okay, we calculate the values of that mean of that average. So return average. All right, so let's call the function. Let's say we call the function now with different average numbers. Average 1 equals to calculate average. We call the function now. We pass 4, 8, 12. Average 2, calculate function again. Pass 5, 10, 15, 20. So I want to look for average for this. Average for this. And this is 3. This is 4. So we make it function open. You can pass 10, 20 numbers. Depend. You can pass the data set to it. I mean, a whole data set. All right. Remember last time we created a data set. We call it. You can create another data set and call it any name you want. Then you can just pass it here instead of just only one number. 2, 3, 4. Just pass data set into it straight. Or data frame. It will calculate our average for us automatically. All right, so let's run this function and see what I'm talking about. Run this. All right, so then let's run these 2 lines of code. We have run this. So let's print. I want to print average 1. Okay, let's print average 1. Okay, average 2. So you can calculate manually this plus this plus this divided by 3. This plus this plus this divided by 4 should be able to give you the same answer. Okay, so that's what we do manually. So this is how to create a function with the variability of arguments, okay, or variable arguments. All right, so we have a function to calculate 2 pi r squared. Okay, it's the area. Let's say we want to the area of a square of a circle. Now we consider 2 pi r squared. This is 2 times pi times r squared. Pi in r is a inbuilt parameter in r. All right. Of course, you understand mathematically that pi is 3.142. Is that correct? 3.142 in any mathematics. So, but this particular value is only to pass into the R. R understand when you say pi, R knows what pi is. So you already had inbuilt for pi. So you must use pi to pi. So you don't need to write 3.142. So if you say calculate area, for example, function radius. So we want to calculate radius. So what we like, we just want to pass in is just the radius only. Radius, okay, of the circle. So we pass the radius. So area equals to 2 times pi times radius square as a pi r square. So radius square. So this is square. You use this to denote square, right? So now this is what we pass out. We calculate this now. So return the area. So area will be returned. Okay. So now if you run this function, okay, we can change the number of radius as many times as possible. Radius can be 20, can be 40, can be 50. So let's say radius equal to 5. Okay, just say radius equal to 5. We can now say result calculate area. We call the function now calculate area, which is our function here. Okay, we pass our radius into it. It's just a way of say that our radius already has a value. You can just remove this one and put 5 here straight. Understand? It doesn't change anything. See the same thing. Okay. So if you run this now, you can print the result out. The result is the result of the area, result of the area is the result. So we want to print out the result now, so you can just run this to give you the result of the area is so 157 we call it now 0.157. All right. Maybe probably you may want to make it you may want to round it to two decimal place. This is so long. You can round it off. You can say round. Just can say here round. Right. Okay. Area open bracket. Say round. Comma 2. So we want to round to two decimal place now. So instead of using this long, could be 157.7.08 probably. So let's run this line again and see error. There's error here. Calculate area. Let me round it from here. Round. Okay. Calculate area. Okay. Round. Calculate. So here we have round. Calculate area radius. So this one close. This one close here. So let's try again. All right. So okay. So now we have a print. You can print now. The area is what? 157.08. So this one is approximated to 08. So this is how to round to decimal place. Just round it to decimal place. So that is how to handle functions in R. So you can explore more on functions in R. This is just introduction to functions. There are many areas of functions that we can auto create later, more of it later while we deal with a control structure. So control structure is another thing we want to look at now. It allows you to control the flow of execution of the program depending on the runtime conditions. We have if, we have for, we have while, and do loop. So all these ones, they are control structure in R, help you to control the flow of the program. All right. The first one is if else condition. Okay, we are trying to test the condition, for example, if else. So we say s equals to 10. So if s is greater than 5, print s is greater than 5. Close. All right. What I'm trying to say here, we're trying to say s y equals to 3. So it's another one. This one's for if else now. We are done with this now. We are done with this. So if this x now greater than 5, which it is, print s greater than 5. If not, print otherwise. So let's print this. Okay, so if you change this one now to 11, that is not controlled by this particular program. You see that will be controlled by else. Let's run and see. What nothing will be printed out because it's not greater. See, it's not printing anything out. Why? Because we didn't handle such a condition here. All right, so let's undo. So let's look at this second example. If else, now that one just basically if. So for if else, y equals to 3. So if y greater than 5, print y greater than 5. Else, we close the bracket here. Else, print y is not greater than 5, or y is less than 5. Okay, okay, print y is less than or equal to 5. All right. So this is saying that greater than 5. So it can be less than or equal to. Okay. So it means y is not greater than 5. So we can print this out now and see the result. Okay, y is not greater than 5. Why? Because y is 3. All right. So if y is 5, you see give you the same thing. Why? Because it's not greater than 5. Okay. See that? Unless you say y is greater than or equal to, then that is when you now have that. All right. So that is just to control the flow of both greater than and less than. So use else condition. So we can have nested if element else statement. For example, we can say z equal to 0. For example, if z equal to greater than 0, print z is positive. Else, if z is less than 0, print z is negative. Else, print z is 0. So we are controlling three condition now here. So we can say that if whatever you pass across around it pass to our z here should be what we control these particular conditions. So if you run this now, z is 0, right? Because z is truly 0. So if you now change z to 5, for example, you should be able to print something else because z is now 5. Okay, let's run. Z is positive. If you print minus 5 here, should be print to c is negative. All right. Okay, you can see that. So we're trying to see how to control this element, this particular conditional statement. So another thing is that a function to categorize student performance, for example, can write a function. Now we are now mixing function together with if statement now. So control structure combined with function now. So that's why we first do function first to have understanding of what function is. Then now we can now make use of our function here in our control structure. So now we want to create a function called categorize performance, which is this function score. We want to pass in the score. So if the score is greater than or equal to 90, print excellent. Else, if the score is greater than or equal to 80, print good. Else, if the score is greater than 70, print average. Else, print poor. So this is our function. So we can run this function first. Okay, we run the function first. Then let us now use the function now. Let's call the function by passing parameter. Let's test the function. So let's assume we have student score 1, student score 2, student score 3. So we have 95, 82, 68 as the student score. We want to pass them consecutively into our function one by one. So let's add in performance. Let's say the performance of student as heading. Then we have categorized performance. We call the function here now. We're passing the first one, 95. So what should we print out? It should print out because greater than 90 should be excellent, right? So the second function should be able to be, if you pass the second function in, that should be good. If you pass the third function in, that should be poor. Okay, this one should be poor because it's not greater than equal to 70. So let's test them one by one. Let's pass in this first, score 1. All right, we have run this. So let's try to run this and see the result. Okay, so the excellence. So if you change the one to second one now, let's change to 2. What do you have? You have good. 3. You should be able to have 4. All right, good. So that is how we pass our parameter to the function. So we also have what they call while loop. While loop. Execution. This executes a loop while the condition is true. So we want to say condition count equals to 1. We just want to initialize count as 1. So if we call the variable count as 1. So we need to use this variable very carefully because it's inbuilt. Count is inbuilt in R. Okay, so you have to be careful with it when you're using it. So while count is less than or equals to 5, right? Open bracket, print count, then add 1 to count each time until it is up to 5. This condition is true, right? So this is our condition now. Count is less than or equal to 5. So we'll be adding 1 to count, 1 to count, 1 to count until we reach 5. Then to print count is sort out. So let's run this line code and see what I'm talking about. Okay, 1, 2, 3, 4, 5, because count is 1 already. So now y is less than or equal to 5, print count and keep adding to count. But this condition until you reach 5. So you can make it 10, for example, 10. So it will until you reach 10. Okay. All right. So this is how to print out. Right, so I didn't start from count equal to 1. So let me put that here so that I can just print everything out together. Okay, you can see. So while loop for calculating factorial, for example, factorial is for example, the factorial non-negative integer of n, we call it n factorial, is the product of all positive integers less than or equal to n. So for example, n factorial equal to n into n minus 1 times n minus 2 times n minus like that till you reach the final number, okay, which is n. All right, so let's say number we are looking for is factorial is 5, which means 5 factorial. We call it, we do like this 5 factorial. That is what we are looking for. Is equal to n into 5 into 5 minus 1 times 5 minus 2 times 5 minus 3 times 5 minus 4 times 5 minus 5. We stop at 5 and we have reached the end. All right, so to give you the result, so that is loop. Now we are going to say number is equal to 5, factorial is equal to 1. So we initialize factorial as 1. Then y number is greater than 1, factorial is equals to factorial times number. All right, so why this condition is true, do this calculate, perform the calculation, then add, subtract 1 from number. Okay, subtracting 1 each time until you reach this particular number. All right, so print the result out. So we should be able to have the result of the factorial of our number. So let's run this function, this particular code first. Then we can print out the result. Factorial is what, 120. So if you do it manually, you get 120. Factorial of 5 is 120. So we also have for loop, which is a fixed number of times. For example, basic for loop printing, we have for high in 1 to 5, print high. This is very simple loop, which means I can be any variable, can be A, can be B, can be C, can be var, can be count. All right, 1 to 5, print I. So it's very simple, just 1 to 5, that's all. 1, 2, 3, 4, 5. That's what it's saying. From high in 1 to 5, print I. So it's a print 1, 2, 3, 4, 5. If you want to 10, print 10, print high to print that high out, which is 1 to 10. So we can use for loop to calculate the sum of elements in the vector, for example. This is a vector, okay, vector numbers. All right. So this vector now has been created. Now we can calculate the sum of this vector now by using for loop. Say sum equals to 0, for example. Now say for we initialize sum to 0 first, then for n in numbers like we did here, for n, for num in numbers, this is a new variable we created now. In these numbers, okay, in this particular factor, that's what I try to say, then sum equals to sum plus number. This is our iteration. So for this particular condition, sum everything together, keep summing. So and the print result out. So that's what we do here. So we can now run this line of code. So which means we can now print elements out, what is inside out. So the sum is 28. So to keep adding to sum this one add together the factor. So that's what we just did. If you sum this together, we should be able to have 28. So this is how to generate that. So we have how to generate, for example, Fibonacci series or Fibonacci series. So it's a sequence, okay? It's a sequence, and in mathematics and programming, it's a series of numbers where each number is the sum of the two preceding ones, usually starting with 0 and 1. You can start with any number. I can have it 2 and 3, 4 and 5, 6 and 7, but usually use 0 and 1 to start. So if the method is f of n equals to f of n minus 1 to f of n minus 2, and continue like that. So we have this for first and second number. So generate Fibonacci, for example, you create a function, for example, for the function terms. The term is one number I want to pass in to the Fibonacci series. So Fibonacci sequence numbers equals to number terms. So we want to create Fibonacci of that number terms. So initialize the first two elements. We have a Fibonacci 1, Fibonacci 2. So the first index is 0, second index is 1. Don't forget this is index now, like you are dealing with a matrix or vector, for example, vector. You have first index, second index, which is 0 and 1 in that particular array of numbers. So we can now create for it. So let's first run this line of code. This function now, this function, for the function begin from here, we continue, and we now say for I in 3, so to terms, this start from 3. We have done 1 and 2. This is 1, this is 2. So start from 3 to terms, the number of terms. So we don't know the terms yet. So we are going to supply the terms ourselves. So that will be the last number. Fibonacci sequence of I equals to Fibonacci I minus 1 plus Fibonacci I minus 2. This is the formula we are trying to pass here. All right. So when we are done, now say return Fibonacci sequence. Then specify, that is what we are returning now. Okay. So specify, that's now the number of terms now. Let's say 10. This number of times, say we are saying, okay, let's say 10. Return the number. So if we run this code now, we should be able to have our result. Okay, let's just run the function first. Function finishes here. All right. So let's pass our, let's say our time is 10, for example. Okay, let's now the result means let's run the result. Fibonacci result equals to generate Fibonacci number of times which we have specified here. Okay, it's 10. So we can run this line of code. We can now concatenate say Fibonacci sequence first number of terms. All right. So now get the result here. So let's just, this is just a string of information just to run to see Fibonacci sequence first 10 terms. That we are trying to say first 10 terms. Okay, 1 0 1 1. So what you are trying to say is that 0 plus 1 equals to 1, 1 plus 1 equals to 2, 2 plus 1 equals to 3, 3 plus 2 equals to 5, 5 plus 3 equals to 8, 8 plus 5 equals to 13, 13 plus 8 equals to 21, 21 plus 13 equals to 34, and 34 plus 21, continue like that. That is what it's doing. So that's called Fibonacci sequence. All right. So this is how to generate sequence numbers. Okay. In how, depending on the type of sequence you want to generate, we have several kind of sequences. Okay. So this is called functions and control structures. If, condition, while, and loop. So these are very useful in how when you are writing a program, which we will be using some of them later as we continue in this course. So that is what we're able to cover today. So I will see us in the next class where we'll be doing something more very important. Thank you so much for listening. I'll see you in the next class.